students. Now we come to lecture 10. In lecture 9, we had studied the rear axle and the four forces that act on the rear axle. I had asked you to revise those four forces and torques to understand this lecture better. Just to revise, the four forces was body weight, torque reaction, driving thrust and side thrust. Now let us look at the two types of rear axle drives. The two types, one is the Hotchkiss drive and the other is the torque tube drive. Figures are shown here. Let us take the Hotchkiss drive first. This is the chassis. This is the rear spring, the wheel. Now in this, the spring at the front end is rigidly fixed to the chassis, while the rear end is connected to a shackle which can swivel. The spring is rigidly fixed at the center through U-bolts, as I had mentioned in the last lecture, with the rear axle, as you can see. The drive is coming. This is the gearbox shaft, output shaft, and there is one universal joint provided here. There are two universal joints. As I mentioned earlier, there are two universal joints in this drive and only one in this. We will see why. Universal joint, this is the propeller shaft, the second universal joint, and then the bevel pinion shaft going into the differential. Final drive and the differential, which we have already studied. There is a sliding joint here. When the propeller shaft length varies due to movement of the propeller shaft up and down, or the length will vary, and therefore the sliding joint makes that adjustment. This is the gearbox shaft. Now let us read this again so that you understand fully. The Hotchkiss drive is the simplest and most widely used type of rear axle drive. Here, now we come to those four forces. The springs, besides taking the weight of the body, also take the torque reaction. You will see how. The driving thrust and side thrust. The propeller shaft is provided with two universal joints and a sliding joint. Sliding joint and two universal joints. The spring is fixed rigidly in the middle with the rear axle. The front end of the spring is fixed rigidly on the chassis frame, while rear end is supported in the shackle, which is free to swivel. The driving thrust is transmitted to the frame by the front half of the spring. As we know, the driving thrust through the differential, it is transmitted through the front half. Front half means the driving thrust from here comes here and comes to here, and it moves the vehicle, the chassis forward with the body on top of the chassis. It gives the driving thrust. Now let us see the working. Due to the torque reaction, we had studied torque reaction in the last lecture, the spring deflects. Torque reaction was, just to revise, to explain to you, suppose we hold the wheels when we were studying the differential in lecture 9, then the bevel pinion tries to revolve around the crown wheel. But that's not so. We can't hold the wheel. When the propeller shaft is moving, the engine is running. So the torque reaction comes, and since this is trying to revolve, the spring, front end of the spring is deflected, as you can see. Thus torque reaction is taken up by the spring. Similarly, when there is a braking torque, it will be in the opposite direction. This is acceleration moving forward. With brake, the torque reaction will be opposite, this way. Similarly, to take up the braking torque, the spring would deflect in the opposite direction. Right. When the spring deflects, the bevel pinion shaft also changes its position. Spring is deflected, the bevel pinion shaft, naturally, if this is deflected like this will tend to move like this, and this bevel pinion shaft will also move, because this is trying to rotate like this, clockwise like this. So this position will also shift. The bevel pinion shaft will also shift because it is with the differential case. Therefore, if there is only one universal joint at the front end of the propeller shaft, it will bend under the rigidity. If this universal joint is not provided, then all the load will come on this universal joint because of this torque reaction. It will bend under this grip. To avoid this, another universal joint. Therefore, this is the reason why a universal joint is provided at this end also. Again, clear till now? Now, when the rear axle moves up and down, when will the rear axle move up and down? There is a speed breaker which comes, it will move up and down. If there is a gadda on the road, it will move down. If there is the speed breaker, it will move up. So, the axle moves up and down. It has to move in, again when the rear moves up and down, it has to move in a circle with center as the front of spring support at the frame. When it moves up and down, the center will be, this will be the center. Because it is rigidly attached, it will move about this. It will move about this because through the springs, the spring is rigidly attached to the rear axle casing. So it will be about this point. This will be the center of that point. It will move in a circle. However, and that is for that, and for the propeller shaft, the center will be, for it's moving up and down, we're still considering that. The propeller shaft center will be this. However, for propeller shaft motion, the center is at the front universal joint. The movement up and down, इसका center ये है, propeller shaft का center ये है. दोनों में अंतर है, there's a difference. So, this means that during the movement of the rear axle, the length of the propeller shaft has to vary. So naturally, when this moves up and down, the length will vary, and for this reason we provide a sliding joint. We had studied sliding joint when we had studied the chapter on propeller shaft. So all four forces in this tube, in the Hotchkiss drive, have been covered. I hope you understood. The other type is called this is the figure, is the torque tube drive. Let's look at this. The difference is, this is the frame. Now the shackles are provided. This is not rigidly fixed to the chassis. Both sides, both ends of the spring have got shackles. The spring from the center is rigidly fixed to the rear axle, in this case also. In this there is a torque tube. In the torque tube, that's why it's called torque tube drive. The propeller shaft is inside the torque tube. One end of the torque tube, as usual, is fitted into the differential casing. Rear axle, differential, and the other end is spherical in shape. This is spherical in shape. This is a coded view of this. We will come to this later. That means the propeller it is spherical in shape as shown. In this type of drive, the springs take only the side thrust. Besides supporting the body weight, only the side thrust and the body weight is taken by the springs. The other things, that is torque reaction, braking thrust, is taken by the torque tube. Let us see how. The torque reaction, braking torque and driving thrust are taken by another member called the torque tube. This is the torque tube. Inside is the propeller shaft is inside. One end of the torque tube is attached to axle casing, while the other end, which is spherical in shape, as I told you, fits in the cup fixed to the frame. This cup is fixed to the frame here. You see, it's fixed here. This cup is fixed to the frame, that is, the cup cannot move. So, this is the blow up of the cup. If you can see, this is the torque tube, spherical in shape, it fits inside the cup. The cup has got a sort of circular cavity where the torque tube comes and fits inside. The propeller shaft is inside this, and this is the shaft coming from the gearbox. This point is fitted with the universal joint. That is, the propeller shaft and the gearbox shaft are connected through a universal joint. As seen, the torque tube encloses the propeller shaft. Since in this case, the torque tube takes the torque reaction, it will not through this, not on this thing, in this case, Hotchkiss drive, this will take the torque reaction. The torque tube will take the torque reaction. The center line of the bevel pinion shaft will not shift. Center line of the bevel pinion shaft, this bevel pinion shaft is here, will not shift because there is a torque tube. Propeller shaft is inside. It will not shift, and further it will always pass through the center of the spherical cup. So the center line will always pass through the center. This is rigid. Torque tube is rigid. It will always pass through the center. So there is no need of a universal joint at this end. Only one universal joint is provided here. Here there were two universal joints because the motion was different as we studied. Here it's different. The propeller shaft is connected to the gearbox shaft by means of universal joint exactly at the center of the car. Exactly at the center. For your notes purposes, I did this so that you can prepare. Notes are also important. In such a situation, no universal joint is needed at the rear end of no universal joint in the torque tube drive. Also, no sliding joint is provided. Why? Because both the pinion shaft and the propeller shaft in this case will move about the same center, that is about the center of the spherical cup. The pinion as well as this propeller shaft will move about the center. There is only one center for both. That's why there is no need of a universal joint. Universal joint you had studied earlier. The reason why it's provided, at an angle, when the drive is at an angle, universal joint, and constant velocity joint is when there are two universal joints, it becomes a constant velocity joint. Both of them in this case will move about the same center, that is about the center of spherical cup. So here clearly both the torque reaction and the driving thrust are taken by the torque tube as we saw earlier and explained earlier. Initially, first time, you may find it a little complicated, difficult. Revise it once or twice and you will fully understand the concept of both these. Now note in what happens instead of coil spring. A coil spring cannot take any. You know what is a coil spring? Which cannot take side. It cannot take side loads. It can only take vertical loads. A transverse radius rod is fitted approximately parallel to the wheel axis between the axle casing and the chassis. Between the axle casing and the chassis, which we had shown in the lecture 9, and they called it the panhard rod. That takes the driving thrust. This was discussed in the previous lecture. Just go through that panhard rod. I had showed you the figure also of panhard rod. How is it placed? And radius rods, panhard rod. You can go back and see that again. So this finishes lecture 10. Lecture 11, we will go to the next topic of Unit 2. Thank you.